Hey everybody, it's Mr. Carr again. And today we're talking about 7.2, proving triangles are similar. Okay, so we're going to use that whole idea of proving again, just like we did back in Unit 6. Okay, these are similar to what we did in before, but they definitely have their own unique things. So the first one we're going to use is what's called angle-angle similarity. If two pairs of angles of one triangle are congruent to two pairs of angles of another triangle, then the two triangles are similar. So we look at this right here. I have a pair of angles here and a second pair of angles here. So therefore, this is true because of, we say, angle-angle similarity. Okay, we don't need the third angle because if you remember from Unit 6, the third angles theorem already states that these two are congruent to each other. So as long as two pairs of angles match up between the two triangles, we have similar triangles. Okay, and remember, similar means they're not congruent. So there's going to be proportions. So for example, I could do JK divided by XY is going to be the same as KL divided by YZ. They're going to be proportional to each other in this case. In fact, let me just do all the sides. And that means it's also equal to JL divided by XZ. Okay, so I can do like these two right here, or I could do these two, or I could do those two, the first and the third ones. So those are all going to be similar or proportional sides to each other. So determine whether the triangles are similar. If they are, write a similarity statement, explain your reasoning. So we have 22 degrees here and 68 degrees down here. What's going to help us is if we know, and well, I should say we already have one pair of angles with the right angles. So I need one more pair of angles to use our angle-angle idea. So let's find this length here. We can apply the fact that 22 plus the measure of angle F plus 90 is equal to 180. Okay, so I can subtract that. So I'll take 22 and 90, put those together. So the measure of angle F is equal to, the measure of angle F plus 112 equals 180. Subtract that over so that the measure of angle F is equal to 68 degrees. All right. So that means I have a second pair of angles between F and C there. So that means, yes, they are similar from angle-angle similarity. Okay. It also asks for a similarity statement. It works just like a congruency statement. The only difference is we're going to use that little squiggly line. And that's it. We're not going to do the congruency symbol with an equal and a squiggly. It's just the squiggly line. So when I look at this, I just got to make sure everything lines up just like we did before. So if I say triangle ABC, okay, so I'm starting here. That's the 22 degrees, 90, and then 68. So we're going to do the same thing on the other one. It's similar to triangle. Starts at D is for 22 degrees. Then I go to 90, which is E, and I finish at F. So triangle ABC is similar to triangle DEF. That's what that symbol means, is similar to. Okay, so reminder, we have things like this where we have our reflexive property. Okay, I think that's what we're looking for here. XZ is congruent to XZ. Okay, it's reflexive. And I think I introduced this before, but we can also talk about reflexive angles. For example, here, if I have this triangle, okay, so I got the blue triangle. Pull that off the side there. And then I do my red triangle is the other one. Okay. The thing about those two is that they shared this spot right there. Okay, that overlaps. So that means that this angle here and this angle here are reflexive as well. So these are my reflexive angles. All right. So in example 2, given the measure of angle RTV is equal to 49 degrees, the measure of angle Q is 49 degrees, prove the two triangles are similar. So there's our proof. We're gonna do the 2 column again. So the measure of angle RTV equals 49 degrees, and angle Q, should be measure of angle Q, but whatever, also equals 49 degrees, and those are given. Okay. So the easiest thing I can do here is the fact that angle R, okay, angle R, and I'll split it up. I'll use the 3 letters in this case. So angle TRV is congruent to angle QRS. Okay, so I did TRV and QRS. Again, it overlaps. Those are reflexive angles. Okay, so they're reflexive. So what I have, so I know that RTV and angle Q measure have the same measure. So I can now state that triangle RTV is similar to triangle RQS. And that's because of angle-angle similarity. Okay. For this one, I'm not going to fill out the chart. I'm just going to say this. We know we got parallel lines here, and then that means this is a transversal. So we get to look back all the way back to unit 5 in first semester. So at parallel lines cut by a transversal, we have other angles that are congruent to each other. So we know that this angle here and this angle here are corresponding angles. And you know, I'm just going to go ahead and do this. All right, so it's given that angle L is congruent to angle OMP, and that's given. I also know that angle, we'll do MNL, is congruent to angle OPN, because they're corresponding angles. Okay. That means I can now do that triangle LMN is similar to triangle NOP. And again, that's angle-angle similarity. Here's a pair of angles. Here's a second pair of angles. Okay, so that proving process looks a little different right now, but again, the goal is, can I get to a similarity statement? If I can, then I have to have angle-angle as one of my reasons, or one of the next ones coming up. Okay, so you try now, you can give that a shot. Our second way of proving triangles are similar is what's called side-side-side similarity. If the 3 pairs of side lengths of 2 triangles are proportional, then the triangles are similar. So what that means, if I look at these, so we got AB, if I take AB over RS, that equals AC over RT, and it also equals BC over ST. Okay, if all of these are the same proportion, that means triangle ABC is similar to triangle RST. Okay, so that's what we're trying to show here. It has to be 3 pairs of side lengths of the 3 pairs that are proportional to each other. So that's what we're going to look at here. Is either triangle similar to triangle ABC? So this is my like reference triangle right here. So we're going to start with triangle DEF. Okay, so let's see here. And when I do these, I think we talked about similar before. I want to make sure I line up like to like. What I mean by that is if I look at the smallest side is 6 here, the small side here is 4. So I'm going to do that as 6 over 4. Okay. My second proportion, I'll do the medium side is 9. The medium here is 6. I'll do 9 over 6. And then my last one is 12 and 8. Those are my 2 largest sides. So 2 ways I could do this. I can do cross multiplication and double check that. Okay, I should get like, I need to double check this one, and then I would double check this one. Okay, if I get true statements in both cases, then yeah, they're similar. So I could just do 2 sets of cross multiplications there. The other thing I can do is I can reduce all of these fractions and see if they're all the same. And that's what I'm going to do in this case. Here I can divide by 2 in both cases, so I get 3 over 2. Okay, here I can divide by 3s, so I get 3 over 2. And here I can divide by, divide by 4s, and I get 3 over 2. So therefore, triangle ABC is similar to triangle, let me just make sure it's going the same order, because ABC goes like that, so it goes small, medium, large. So I want to go small, medium, large. That is DEF. And the reason is side-side-side similarity. Now remember, this is different from congruent. Congruent triangles have 3 pairs of congruent sides. The 2 triangles are congruent then. Here, the 3 pairs of sides are proportional. Let's also check triangle. Let's see here, small, medium, large, GHC or GHJ. So again, we're going to do small, medium, large. So if I do that as 6/16, that's small to small. We got medium to medium. We got 9 to 18. And then I got 12 and 24. So the question is, are all 3 of these the same? You see it quickly enough, it's not, because 9 and 18 is 1/2, 12 and 24 is 1/2, 6 and 16 is not 1/2. That would have to be 8 and 16. So instead I could divide by 2 and I get 3 and 8. So they're close, but that is not the same proportion as the rest. So these are not similar here. Okay. All right, find the value of x that makes these similar. So again, this is just setting it up as kind of like we did problems before. We're going to set up proportions based on the given information. So when I look at this, so we got ABC, so AB and DE are in the same positions. So are BC and EF. So I could use the 2x plus 3 if I really wanted to, but I'm going to make it easier. I'm going to go x minus 3 divided by 20 is equal to 4 divided by 10. That way I just have to deal with one algebra expression instead of both. So I'm going to go ahead and cross multiply there. So I have 10 times x minus 3 is equal to 20 times 4. We'll distribute the 10 so that 10x minus 30 equals 80. We'll add this over. 10x equals 110. And then we'll divide by 10 so that x equals 11. Okay, so that means if x is 11, that would make all of these sides proportional to each other. All right. One last possibility is what's called side angle side similarity. And again, this is different from our congruent triangles. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides that include these angles are proportional, then the triangles are similar. Okay, so in this scenario, I know that x and m are congruent to each other. So angle x congruent to angle m. That's the A part of my side angle side. If I can show that xz divided by mp is equal to xy divided by mn, okay, if this is true, then triangle xyz is similar to triangle mnp because of side angle side similarity. Like that. Okay, so that's our goal here. Can we show that in this next example? So what I'm going to do is I'm going to treat them as 2 separate triangles. You don't have to draw it out like this, but I'm going to just so I can see a little bit better visually. So we have 4 and 5, and that's point V there. Then we got the big triangle is made up of, that'll be 12 and 15. Now I'm putting the point B there because I do know that that's right there. Angle V is congruent to angle V because they are reflexive. So I do have my pair of angles that are congruent here. The question is, are these sides proportional? So we're going to do 4 and 12 and 5 and 15. Let's see if they come out to the same thing. So in this case, I am going to do cross multiplication just so you can see how it works on this one for testing. So it does 4 times 15. Does that equal to 12 times 5? 4 times 15 is going to give me 60. 12 times 5 also gives me 60. Checks out. Okay, so what I have is proportions that work here and here. And then I have the included angles are also congruent. So yes, by side angle side similarity. Okay, so that's what we're testing out. So quick recap of today. For me to know that 2 triangles are similar to each other, not congruent, similar. The first case was angle. So if 2 pairs of angles match up to another 2 pairs of angles, so 2 pairs of angles match up between 2 triangles, then they are similar triangles. Okay. Then there was side, side, side. If all 3 pairs of sides are proportional to each other, then the 2 triangles are similar. And then there was side angle side. So if the included angle of two pairs of proportional sides are congruent. Sorry. If two pairs of sides are proportional and their included angles are congruent, then the two triangles are similar to each other. Okay, so three main reasons. That's what you're going to use to work through some of our similar triangles here. Okay, that is it for today. Take care, everybody.